There are many things which if done step by step or bit by bit will give much desired result than done otherwise. Learning to cook bit by bit, losing weight bit by bit, impressing boss at work bit by bit, moving bit by bit to reach your place, working on that proposal bit by bit, and so on. In my last video, we did the logical operators and, or, not. Remember? Which by the way works on a data type as a whole one single entity. In this episode, we are gonna do the bitwise operators which will give us the desired results bit by bit. But pehle, I want you to subscribe to my channel so that you do not miss out on any of my videos. Let's first have a quick recap of what we have already covered in C operators. For detailed explanations, description में दिए links पर जाकर आप मेरे videos देख सकते हैं. We have seen what operators are, how many types, what are unary operators, arithmetic operators, relational operators, logical operators, and how they all operate. Today we will cover bit by bit operators which also are a binary type. For clear understanding, let's take the case study of a cinema hall where only 3D action movies are shown. The owner makes a profit only if minimum 75% of his hall tickets are sold per day. Let's say in this 8-bit representation, the 7 days are represented by 7 of them, that is from Monday till Sunday. And since we don't need the 8-bit in our example, we will make it a dummy. Now in these days bits, if the hall is occupied by more than or equal to 75% of capacity, we will denote the bit by 1, else a 0. Let's take the release of Aladdin on a Friday in our example. Since this Will Smith movie is too good, I can't stop myself from showing you the trailer a little bit.
O great one who summons me, I stand by my oath, loyalty to wishes 3.
I'm kidding. Watch this.
Watch out! You done wound me up. You ain't never
Okay,
had a friend
enough.
like me.
Back to our topic. The data of tickets sold in percentage is accumulated और उससे tabulate कर लेते हैं ऐसे. Now we are looking at the hall data of this release day Friday. And since the hall was fully booked for all shows of the day, matlab 100% occupancy as you can see here in the data table, this bit is marked a 1. Now let's take Saturday, again 100%. Saturday bit becomes 1. Similarly, we go on filling the data for whole week as per this table. Let's call it a week 1. Taking the data from this table, we will fill up similar bits for week 2, week 3 and week 4. Now we have all weeks of the month written here with ones telling us the days when the hall owner made money, that is minimum 75% of tickets sold, and zeros telling us when he didn't. Now let's go back a little. Remember this truth table of logical AND operator from my previous video? Only when both operands are true does the result become a true. Similarly, we use something called a bit AND operator. समझ लो logical AND का छोटा भाई. What it does is same operation but with individual bits and not the whole set. For example, if these two are two operands, this 1 and 1 will give a 1, this 1 and 0 will give 0, and so on. Concept clear हो रहा है ना? Now, if the owner wants to find out if there was any particular day of the week which was always the best for business, means a 1 for a particular day in all weeks of the month, isn't this what our truth table says? That result would be true if both operators are true. If one of the operator is false, it is false. And naturally, if both are false, the resultant has to be a false. In other words, if same days of 2 weeks are true, which means that they are money earning, the net result for both is true. So, the owner would start using AND operator with all weeks, taking 2 at a time in order to find out for the month. So now we take the result of week 1 and week 2 by subjecting them with a bitwise and write the result in this temporary byte. The individual bits will give these results for all 7 days. Now let's take this temporary result and bitwise AND with the 3rd week data and store the result in this temporary byte using the truth table. Similarly, take this temporary result and bitwise AND with the 4th week data and store the result in this month byte. What does this net result for the month tell us? Clearly that Fridays, Saturdays and Sundays never fail to hit their mark for the movies, which in turn means that these 3 days are the assured profitable days for this cinema hall. Now let's suppose the owner wanted to see which days of the week always fail, or in other words are always loss making. How can he arrive at the conclusion from the same data? Well, for this our second bitwise operator OR comes in handy and has this as the truth table, which is quite similar to the logical OR operator we had done in our last video. The result can only be false if both operands are false. It will be 1 even if one of them is a 1. Applying this operator to our example, the result of first week and second week will be like this. See, even if one of the operands is a 1, it gives the result 1, but is 0 only when both bits are 0. And then this result is odd with 3rd week and then its result with 4th week to get the final result of the month. From here it is clear that except Thursday, all other days get a 1, which means that Thursdays of all weeks must have been a 0. Anyway, till the owner thinks about that, let's do the next bitwise operator, which is XOR, written by this symbol. The truth table for this one is like this, where it gives a 0 result when both the operands are same, which means the result will be a 0 even if both the operands are 1. And obviously the result will be a 1 when both the operands are different. Let's take the same example operands. Now the result will be this because these bits are same for both operands and so are these. Clear? Next bitwise operator is complement operator represented by this symbol. As its name suggests, what it does is basically reverse all the bits individually. So this example will become this. See, all zeros are made 1 and all ones are reversed to 0. Chalo, let's quickly understand the remaining 2 more bitwise operators, shift left operator and shift right operator. And they are represented by these symbols respectively. The shift left, as the name suggests, shifts the bits toward left, which means in this following example, the leftmost bit goes waste and all other bits are shifted left. And the shift right shifts them towards right. The rightmost bit is wasted and all these are shifted right. Okay? So what happens to the vacuum created in these bits as there wasn't anything left in them after shifting the bits? Well, these are occupied by a 0. Let's now implement these bitwise operators in an example program where we will use 32-bit int type and see how these operate bitwise to give results. Here's a program that we have written in which we have done all these bitwise operations with 2 variables, namely A and B. Let's first calculate the results ourselves. What if A was 15 and B was 3? This means that in equation C equal to A and B, we need to calculate 15 and 3. Now 15 in 32 bits binary will be written as this and 3 like this, right? Now as we have learnt earlier that if we want to do the bitwise AND operation, it will follow this truth table and the operation will happen on individual bits like this, which will result in 3. So C becomes 3 in this case. In our program, next is bitwise OR, which will happen according to this truth table, and the result will be like this. Resulting in 15. So C becomes 15 in this case. Similarly for XOR, the results will be like this, where C becomes 12. Next is the complement operator, in which all the bits are reversed. Well, we do that here, but we also notice that the 32nd bit becomes 1, which means the number is negative. And we will have to get the result by 2's complement method. So we do that and get the answer, which is minus 16. Now the next one is interesting. We have seen in our example of 7 days that the shift left operator shifted all bits towards left by 1 bit. That's because we asked it to move only that much. But in our program, you can see that we are asking A to move by B number of bits. That is, we are asking the bits of 15 to shift left by 3 bits. See, this is how these bits will move and zeros will come in the vacant places, and thus the value of C becomes 120. Similarly, shift right operates and gives us the value of C as 1. Let's now run the program and check all the results with our calculations. Let's keep both results parallel and see. Yes, all are same. Great! Since today's topic is complete, I can now go back and watch Aladdin once again. Also, before you go, please give the video a thumbs up so that I can go on making learning fun for you. Bye bye!